All right, so there's two things we really want to cover. One is PySpark, and the other is getting things set up on Google Cloud. So we'll try to do them both somewhat simultaneously. So I'm going to start with Google Cloud. Uh, the best cloud service out there because my wife works for it, and when you pay money into Google Cloud, it turns into money for us. Totally unbiased. Uh, so you have to be logged in, go to console, and what we're using, it's so fast, so fast. Okay, come on. Okay, here's all the, come on. Take your time. So there's a whole ton of services. Is this because of the screen recording? Right? What we're using is Dataproc. You'll notice you probably don't have it up at the top there. There's some way to, I've pinned this, and that puts it at the top so I don't have to scroll through all of it. All right. So for Dataproc, it automatically sets up a whole cluster of nodes for you, already configured with Hadoop and Spark and all of this stuff. So actually, I have this cluster running here. I'll delete it. So I'll start from scratch here. So you want to create a cluster. Hopefully you can follow along. There's a few places where you might run into trouble where I won't. So we can give this a name. I have no idea why it's defaulting for Asia for me. Don't do that. US East is good. For the assignment, I think it's US East 1B. It says in the command line, always use the same region. So it's the same kind of node that you're always being evaluated on, and the data is stored in that region, right? Locality is really important. If I stored the data on the West Coast and we're accessing computers on the East Coast, we get different performance. For the assignment, it's this default 4 CPUs, but 16 nodes, which that 16 doesn't actually include the master, I think it includes master. So 64 cores total, because they're 4 core each. 192 gigs of RAM. Yeah.
I'm sorry. How did you? So if you have a project, how did you navigate to this page from that project?
I went up here and I went to Dataproc, which if it's pinned will be in this top, but if you just keep scrolling, it's under.
Okay. Yes, I can see all of this below.
Where is it? It's not compute.
Thank you. Sorry.
StackDriver, incidentally, is where my wife works. I think it's a very uninformative name, but it's like monitoring and logging and stuff. Under big data, perfect. We're in big data course, Dataproc. Right. And so we're under clusters. You could probably also make this regional. I don't think it matters too much. The one thing you do need to do that's different is change the default image to version 1.2. This is what the score will be using to test your assignments. I found out the hard way that this newer version has a whole bunch of different defaults and they don't work very well at all, and rather than having a super long command line restoring it to the old defaults, we're just doing this.
Is it normal for like the create the cluster to take a while first?
It will take a while. They brag about how fast it is.
Okay.
I guess it's all relative. The 1.2. If you forget that 1.2, you're going to see in a little bit that the default parallelism will be 4 instead of 62. It should be 60 something. So if you see a really low default parallelism on your Spark cluster, it's because you forgot that 1.2. I have no idea why they thought it was reasonable to default to not running your jobs using all of the cores, but they did. So this will take a little while to spin up the cluster, although I have noticed that it sits here spinning even when it's done. It's not so good at refreshing. Now I'm getting this. That's great. So sometimes I just manually refresh, which I'm sure they appreciate. Some places where you might run into trouble are quotas. So we just did asked for like 64 cores, and sometimes if you're new, your default quota is less. I don't know if anyone's run into that trouble, but you can quota. I'm just going to search for quota. That's the easiest way to find it, although, oh, it's really slow today. Is it this slow for you? Much to my chagrin, there isn't actually a way to search for quotas in here. You have to sort of filter it. No. You're looking for CPUs in US East. So Compute Engine API CPUs. This is the one where you're most likely to run into trouble. We have in the past. You click it and hit edit and fill in this information and blah. And just tell them how much you need. You don't have to be a verbose here. Just say, I need more. You'll get an email back that's like, we'll take care of this in 48 hours. And then about 2 seconds later, I'll get an email saying your quota has been increased. At least that's what happened to me. It was like, you jerks. And then, oh, great. But hopefully you have enough. I think that's one of the main issues. Sometimes there's other quotas that hit. Going back to Dataproc, hopefully it's done by now. So here's my cluster, and I can click on it. There's a spinning thing. So you get some overall usage. It's not doing anything right now. The way we're going to mostly use this, or one way to use this, is by submitting jobs. That's certainly how we're going to score your assignment, and we'll go over the job submission interface. But you can also interactively use it if you want to play with PySpark. So this is your cluster. These are all your virtual machines. So you spun up 16 workers and 1 master, all with 4 cores. So there's actually 68 cores total. And the workers you don't get to access, but the master, which is controlling everything, you can actually SSH into. Okay. And so you can connect to this, and it takes them a while. Right, so these are each virtual machines with 4 cores that you've just created and you can now run things on. While this is getting started, the other important thing here is the web interfaces. And this is just commands you copy and paste. And you can see this is for Linux. I'm on Mac, so I need to switch that. And this is, gcloud's already installed. So what this is doing is it's setting up an SSH tunnel to your master so you can connect to the Spark goodies. And then this is creating a launching Chrome with a SOC 5 proxy server so that it can actually connect through that SSH tunnel. And what you're seeing here is the current status of your Hadoop cluster. So there's 16 active nodes and nothing's going on. So this is going to be really useful. All right, so here I am connected to my master node, right? And I can run Spark. Now, in order to get the environment all set up, if you just run Python and try to import PySpark, it's not going to work. You run PySpark, like literally, you type PySpark here, and this will get your environment. And then if I switch and refresh here, you see now I have an application that's running. And while it's running, I don't know why it says 12 containers. There are 32 containers. And SC, it doesn't tab complete. So the default parallelism here is 62. And that's because it's reserving 2 cores. It says that here somewhere. But so if I can run 32 things in parallel. And if you want to work interactively here, we could do that. What I think I'm going to do, because I'm not sure I can, well, I'm going to switch to, no, I'll do it here. Okay, so I'm going to load a file. So the GS means this is on the Google Cloud. It's on Google Storage, GS. So it should be able to read it. And actually, let me make a point here. So if I'm running locally, I can just import PySpark. This was working a second ago. Oh, huh. I have a file in my temp directory called PySpark. Okay. I was literally doing this. An hour ago. Okay. I don't remove things from my temp directory very often enough, apparently. Okay, so if I'm running in Python, I have to get the Spark context. Tab complete. When you run the PySpark setup script, it does this, initializes this for you automatically. Now, if I get the default parallelism here, it's 4. Why is it 4? Right, I have a quad-core laptop. Right. It's not running on any cluster, it's just running here, but it's still parallelizing it. Now, if I do works equals se.text file, so take gets the first 10 things. I'm getting an error, but here, if I do take 10, I actually get the first 10 lines. This is the complete works of Shakespeare. It says it as the first 10 lines. So why am I getting an error here? Well, if we scroll down, no file system for Scheme.js. Right? You need to install additional software to have a connector to the Google Cloud, and that's just not installed on my laptop. But obviously, it's already automatically installed when you set things up on Google Cloud. For this one, I'm going to, so I can work on locally on my laptop, wget that's the complete works of William Shakespeare, which, in case you're wondering, is only 165 million lines, or 165,000 lines. And now I can just read this locally. So I'm not giving a URL, so it's just going to be a local file. And now I can get the first 10 lines. How is this data partitioned? It's in 2. I showed you last time that the default is 2. Let's see over here. This is also 2. This file is not big enough for the underlying storage to have it broken up into blocks. How do I count words? I'm going to do this locally because I like tab complete. So first I have to convert these lines into words. So what transformation would so this is an RDD, resilient distributed data set, organized by lines. Each record element of that data set is a line. How would I convert that to an RDD where each element is a word? If you're just writing Python to do that, what would you do? You have a list of lines, you want to do a list of words. Split. Yeah, so I am going to map the split function, the string split function on here. Oh, I had a whole point I want to make with this. When I got the error with the Google Cloud not being installed, I couldn't read the Google Cloud file. I didn't get that error until I tried to read the first 10. Right? This line didn't produce the error. And that's because this is lazy evaluation. Right? Me just doing this does not actually apply split. Split is not applied until I apply an action that actually collects the values, like take 1. So, actually, let's take 10. So what happened here? What's the type? What am I storing in my data set? So, what? Sorry, just didn't hear you. a list of lists. So our data set was a list of strings, and now it's a list of lists because split turns a string into a list. What I really want is just a list of strings, right? And so what I can do to get that is to call flat map, which maps onto every element. But then when your map function returns a list itself, it adds the elements of that list instead of the list. And so now I have, and actually I can get the count of all the words here. So almost 1 million words in the complete works of Shakespeare. Right? So these are my words. This is my RDD. So what do you think would happen if I counted by key? So how would I count, if I wanted to count all the words? So there's a count, so tab complete. Count is just going to tell me how many words there are. But what if I wanted to count how many there are of each word? So I don't know about you, but I see count by key, and I'm thinking that's going to do it. So the first thing to realize here is this is not a transformation, it's an action, because it actually returned values. And what was really kind of interesting is, what do you think happened? So it's counting letters, but I believe it's counting only the first letter. Right? So if you're saying by key, it's assuming your RDD is a key value pair. Right? But this is Python, duck typing. So it says, okay, it's a key value pair. It's going to take your element from your record, and it's going to go like this to get your key. It's going to index by 0. So if your element wasn't a tuple, a pair, if it was a string, it's going to say, okay, the key is the first letter of your string. Now I can actually count by value, and that actually does, count does the right thing, but this is an action. It returned the whole result. If I want to do more with this, I want an RDD. So how do I get the counts as an RDD? So I'm going to convert this, and there's like a dozen ways to do this. So if you have something you think is more efficient, go ahead and try it out. But I'm going to convert this to a tuple. All right, let's unpack this. So I went with something where it's just a single value to now it's a tuple, where it's 1. And then I'm going to reduce by key. So reduction applies this sort of additive operator, this thing that combines two things to get another thing. Right? Sum is the most common example, but it's this community thing that you can apply in any order to reduce the result. By key means I'm just going to do it for all the records that have the same key. So it'll be grouped by key. So I'm going to go from an RDD where the key value is in there multiple times, the words are in there multiple times, to where the word is only in there once, it's a key, and I have combined the values into one value. So the values I'm combining are ones, and I'm just adding them together. I'm going to use the built-in integer add. And if I do this, nothing happens. Why don't I see anything? What?
Lazy.
It's lazy, and also the type of this is an RDD. It isn't doing any of this stuff because it's lazy until you actually get something from it. So if I say take 10, there it is. And something else I want to point out is this is now partitioned based on this key. And anytime you partition on a key, there's usually an additional operation. So so here's my counts. Counts.get. So it's keeping 2. But anytime I repartition on the key, I can usually provide another number that tells you how many partitions. Right? So before there was 2 partitions. Right? Just by default, it's going to always split the input in 2 at least. And so here, it probably took the first half of Shakespeare here and the second half here, right? And then when I apply the map, half the results are here, right? So this is word 1, and this is some other word 1, word 1. And then it does the reduction, but it's by key. Right? And there's W word here and W word here. The same word is here. So they have to be combined into the same partition. This is what I mean by we have to repartition it. Because the record has to be in the same partition, right? So there's a shuffle that goes on where this information goes here or vice versa. So we have a new partitioning. So this is a perfect opportunity to tell it, hey, even though this isn't the biggest data and the input file wasn't broken in 2 already, I have 4 cores, so go ahead and break it in 4 since you're breaking it up already. Right? And now everything after this point is going to be that much faster. And remember the difference between reduce by key and group by key. If I had done group by key, what I would get would be partitioned. There would be one instance of that word in a list of 1s, which is stupid. Right? Because ultimately I just want to sum them together. This is not going quickly enough. So how do I get, if I just wanted the most occurring words, how could I get that? So I'll tell you, there's a max function. Why is this the max? Because the double quote character, whatever that ASCII character is for ASCII code for double quote is larger than any other character. That's not what we want. We want the counts. So I can actually give it a function to tell it this is actually the key I want. And what did I do? Lambda. Yeah, different color. Right? Anonymous function. Back in good old Python 2, I could have put a tuple here, but you're not allowed to do that in Python 3 anymore. So KV, which I know is a pair, is a KV key value pair, and going to access just the value and say ignore the key, that double quote, and just look at the value. The largest one is no surprise. Right?
Can you say the difference between chunk 25 and 29 again, the X versus the KV? For lambda X.
So words, if we actually look at words here, it doesn't have key value pairs. Each element in my data set is just one string. Here, I know that it's a key value pair.
After the map?
Because I did this map to make it key value. The reduce by combined all the ones, so now there's a single, by key means there's only one. The word, in counts, the word of is in there exactly once with the value 16,750 cents. Now, but what if I wanted to get the top? So I could, there's actually a sort by. What do I need to change to get the max? Sorry? Descending. So I could just make that negative. So there's the, but this is requiring me to sort. What's the complexity of sort? N log n. What should be the complexity for taking the max k values? No. N times k. Well, no, n. Well, k should be in there. Right, we can, if you're just taking the max value, you go the whole thing and just keep track of this one thing, and you only have to go through there once. If you're taking the k top, you have to keep track of k things, and then that's where the order k comes in. I'm going to use this as a way to illustrate aggregate. Insertion sort might actually be faster here, but I'm not going to implement that. All right, so this is what we talked about at the end of class last time. The do I still have it up here? Aggregation, right? We are going from word count, that's the type string, the tuple of string number, and the ultimately output we want is the list of size k, max size k of the most occurring ones. So the types aren't the same, so I can't do a simple reduction. With max I can, right? Because it's just one thing and it's the same as the things I'm taking the max of, right? But I want to keep the top k. So I can use, there I have a notion of like the result type's different than the input type. That's where you use aggregation. So in order to do that, you need a function that takes the input type and says, here's how to add it to the result type. And then you need a function that says, here how you combine two result types, right? So on one partition in one node, it applies this to create a result type for that partition. Once all the partitions are done, or they start being done, it merges the partitions together with the combination operation. And so that is what I have implemented here, hopefully, of course. All right, so in parallel, on each of those four partitions, it's going to do this. What is this saying? This is the thing I'm accumulating in. If I don't have k yet, then I definitely want to add this word, right? I don't even have the top 5 yet. Or if the count, right, the second value, is greater than whatever is at the end of my list, then I want it because it's bigger than what I've seen so far. I'm keeping the In this case, I want to keep the current pair, so I add it. Then I sort this whole list to make sure that the lowest thing is at the end. Insertion sort here would actually, a simple insertion would technically be faster, but then you have to implement it. And then I just pop off the last thing. So I could do a pop here instead. I'm just keeping the top case. And then I return it. Other thing to note here is if you read the documentation, it's very explicit. You are allowed to add into this. You don't have to create a new data structure. That would be inefficient. Right? You can add into the list, into the dictionary. You're mutating it in place. You're not creating a whole copy. It's not fully functional. For combining two, I have two lists, both of at most size k. I'll just put them together. This is appending the list into A. I'm sorting, and then I'm lopping off the 5 lowest. Right, so these are the 5 most occurring words and complete works of Shakespeare. And I computed that all in parallel. So if you, another way to think about this, which is a bit more procedural, is just, okay, I have all these partitions. I'm going to do as much work as I can within the partition to summarize all that, and then I will combine that together. That's exactly what this is saying. This is the sequence is how to do work in the partition, and this is how to combine them. But this is all within sort of the reduce mindset. If you want more flexibility, that's where map partitions come in. So I can just define an arbitrary function and okay, what this did is it just took the whole partition, this list, this L, is just an iterator over the entire partition. All the data, you're just going over it one at a time. You're streaming it in order. So for each one of those, I'm applying my sequence operator, which is just maintaining this ret, this list of the top 5 I've seen so far. And then I return that. I yield it back. And so when I collect this, I get 4 lists. Why am I getting 4 lists? Because there's 4 partitions. This is not the final answer. This is as much work I could do on each individual partition. And then, and actually, interestingly, they're different across the partitions. I'm not sure what to make of that. Oh, they should be different. They should be non-overlapping, right? Because we did reduce by key, which partitions based on key. So different words should be in each partition, right? If I had not done the reduce by key, which rekeyed it and repartitioned it by the words, then it would probably just be chronological order. But now I should be able to reduce by my combination, which is saying I'm taking as input a list of 5 2 lists of 5 things. I'm going to return a list, right? The types are all the same. So I can apply normal reduction. So this is doing the same thing as the aggregation. But if you have something even more complicated that you want to implement that doesn't fit quite into, oh, put one thing at a time into my list, like if you want to maintain state or something, then you can use this. And this better be the same answer. Okay, good. I know you have to go places. I have to go places. Today is my oldest son's birthday. He's 13, so he's our first teenager. And did you know that September 16th is the most common birthday? Anyone have a birthday September 16th? No? Okay, well, you're uncommon. And September is the most popular month, so you can do some math in your head on that one. All right, so I'm going to make a more complicated function. So here I can have data structures, save state. Oh man, it got complicated. I would not bet money that I'll type this right the first time. Oh shoot, it got caught off in the print off. Prev word. That's a lot. You could use a default dict here, that would be nicer. Oops. Okay, what am I doing? A question I ask myself every day. I'm going to give this to map partitions, that's the context. I'm going to give it to the original RDD of just the lines. So I'm not doing that map to, I'm not doing mapping the split, I'm not mapping to this crazy tuple with the 1 in the reduction. So I'm doing the split here. I'm skipping the first word. And there's the first typo. This is what I want. I want words that start with a capital letter. I'm just trying to get names. It didn't work very well. So it starts with a capital letter, but isn't the letter I, or a single letter. And if I'm trying to get things where the previous word didn't end with a punctuation mark, so it's not the start of a sentence. It's not very successful here. I'm skipping the first word because it turns out all the sonnets in this text at least start, like the first line is a capital no matter what. Like, this ultimately didn't get just names. But so let's see what happens. So here, I start with the original one. Right, so these are capital words in no particular order now. All right, just notice for a second that Gutensberg is 0. Now I'm going to reduce by key. Hopefully this works. Oh, it's still 0. That's funny. I'm getting different results than on my printout.
Professor, in the else statement, if you write equal to 1, maybe.
Oh! I told you there was no chance I was going to write it the first time. Okay. this is 1. But I reduce by key, I get 2. Why do you think that is? What happened? How many partitions are there? 2.
Oh, it's the
There are 2. There are multiple partitions is the main thing. So at no point did I have a guarantee of unique keys. Because I started with the lines. Right? This wasn't enough to get the final answer. I did a lot of the work. I summarized a lot. Right? I went from nearly 1 million words to a few thousand tuples. But I had to still do the extra step after the map partitions to put them together. And then if we want to know the most common ones, we can call this name counts. And then I can just do what I did above, aggregate. Not actually names, but okay. Lord, Duke, King, I don't know. Isle.
what that
That's straight. That is. No, there's a bug. No. Yeah. Okay. So one last thing, we could do that all in Hadoop. Where are we? Here. And we could do that interactively. I just want to do it on my laptop because I like tab completion. But if I have this in a file, sorry, where are we? Where'd you put it? Oh, that why HTML? Really? Bother. I'll just type it. Is that right? How did I spell it? I'll find out. So gcloud, we'll go to the assignment. Wrong one. So from any computer that you're authenticated to, you can, and you've installed the Google SDK on, you can submit. So we say this is their application. I want to run Dataproc. I'm submitting a jobs. I'm submitting for PySpark, and then here's my example. And I'm going to run on the cluster, Recitation, and what's the other thing? No. Everything after the -- are arguments to that Python script. So I don't have any for this one. And let's see if it works. And we need the SC equals import PySpark SC equals. Actually, we could just no. There we go. If you want less verbose output, you can leave that in there. So this is a lot of output, but it's going to be really fast. There's the number, right? That's running your job. Let's actually do this whole thing. And there's no such cluster. Let's do the recitation. So now when I switch to my monitoring here, oh dear. Oh no. These two have finished. There's the random. And the important thing is application master here. When I click on this is going to give me this Spark control panel, and this is telling me the stages. Remember, the stages are a group of all the stuff that can execute together on one partition, and I can see here's all my executors. So in this case, the random is actually doing nothing. Did it finish? So there's like no RDD blocks on any of these. So this is what happened, and you can dig down, and your goal is you want all of these executors, all your cores, to be in use. But the random only doesn't actually do much. Yeah, okay, it finished. But this, okay, I needed something that actually took time. So if you see, not using all the cores, that's bad. This was all it did. If you see so this shuffle, this is the amount of communication it's doing between nodes. You don't want that big. You want to avoid that being big. The whole point, I think the main point of this assignment is thinking about where your data is, how you're computing on it efficiently. The actual machine learning is KNN. There's some maybe cleverness in how you represent your data efficiently and what you mean by closest and how you implement a distance function. But it's really thinking about how you're mapping onto data, doing as much as you can on one partition before you combine the results. Right? You don't want to be doing a full cross product, Cartesian cross product anywhere. And this will be your friend, being able to look in here and actually, like if you're taking half an hour, you can actually go and see what part and what line of your code it's spending all the time on. This didn't, we read the text file, we did a partitioning, there was very little happening here. But line 25, is, yep, that's everything. All right, I read the file. Yes.
Can you show again where it was that we were supposed to pick like that Debian 9 and Hadoop 2.8?
Yeah, so that's when you create your cluster. This is the wrong one. So if I'm late for dinner, it's because Google Cloud is slow. Okay, that's going to go over well. So you should need to change only two things. One is the number of nodes, make that 16. Of course, for debugging, just the first thing, work on the small data set on your laptop. That's fine, right? But once you get it working and you submit it and you're like, it's taking 40 minutes and you figure that out, then rather than trying to iterate by submitting blindly to the server and getting an answer back, spin up your own cluster, connect via the SSH tunnel with the Spark thing and see where all the time is being spent. So you change this to 16. And advanced options, image, change this to 1.2. So first step in the assignment, get it working with the small, there is a small data set, right? I'm not, yes, there's a small data set. Get that working on your laptop. Once you have that working, you can submit it. I would not be surprised if it comes back timing out after 45 minutes, but if it doesn't, consider that a great success. And then spin up the cluster and start testing and developing with the medium and the large on your own cluster.
You're getting an error from the 16 node things about like
Quota?
insufficient.
Yeah, that's where you go to the quota. Just search for quota. It'll come up. Find the CPU. Click on it. Click edit quotas. Give them your phone number. Tell them you need more. Don't be greedy, or they might say no.
How many would you need for 16?
Well, you need 68, so say 72, just so, They gave me 144 within like a couple minutes of asking. So. And there's quotas per region. So, like, just stay in the U.S. East. We're in the East. That's why. Are those centrals Iowa? I don't know if closer is Iowa or South Carolina. But. Other questions? Very good. All right, so good luck. Really don't put this off. Yeah.
Oh, so you were reporting this. Is
Yes,
this
I'll
available?
post it. Yeah.
Okay, great.
Yeah.
That would be
I don't know how well it's working, but I have to click here. Okay, I'm going to stop recording unless there's any other questions.